Trigonometric. Let's say we have a question like this: limit x approaches 0, tan 4x divided by 3x. Now tan 4x we can expand it like sin 4x over cos 4x. Let's do that one first. If we do that, this is going to be limit x approaches 0, sin 4x over cos 4x times 1 over 3x. And whenever we have a sign in the numerator or denominator, like whenever we have a sine function, we had to always think like, can I bring it to this pattern? Sin x, like as limit x approaches 0, sin x over x. If I bring to this pattern, I can equate that one to 1. So I have to have the x value after sine, and the denominator has to be same. To bring this one into that, what I'm going to do is I'm going to multiply the numerator and denominator by 4. Okay, so let's put this one in the box, this one just for the substitution later. So if I do that, this one can be written as limit x approaches 0, then sin 4x. Now what I can do is instead of 3x, I switch the 4 and 3. So instead of 3x, I put 4x here, and I bring the 3 to here. Okay, also you can now we have cos 4x, and we already took the 4. We have 3 left. Okay, and 4 and 3 left on the 4 left on the numerator, and then 3 left in the denominator, and cos 4x. Okay, now we have this one. You can also write this one as, a better way to write it is take the constant away, just put 1 right here, and put constant separately like 4 over 3. This one looks good. Okay, now what we can do is whenever we have a constant multiplication with x, now we have brought the whatever the value after sine and the denominator same, like this pattern. But the only thing we had to do is we had to make this one also equal. For that one, what we do is we substitute 4x for y. Y is equal to 4x, and whenever we have x approaching 0, then all the constant multiplication of that one approach also 0. So we can say limit y approaches 0. There, and instead of 4x, I replace that one with y, because we equate that one right here. Sin y divided by y, and I'm going to express this one as limit x approaches 0, 1 over cos 4x times 4 over 3. Now this whole thing is 1. This whole thing is 1, so we can say 1 times, and then cos 0 is cos 0 is 1. So this is going to be, I can do the direct substitution here. So this is going to be 1 over 1. You can put cos 0 and do one more step, but we can just put 1 right here, and then 4 by 3. Therefore, the final answer is 4 by 3. That's our final answer. Now let's look at another problem. I'm going to erase this one. Let's say we have a trigonometric function given like this. Limit x approaches 0, 7 times 1 minus cos x divided by x. If you watch my first part of this video, we had two equations. One is, when limit limit x approaches 0, sin x over x is equal to 1. And we have seen another equation, that is when limit x approaches 0, 1 minus cos x divided by x is equal to 0. If you look at this one, we are having the second situation right here. We can substitute this one in this equation. But we have a constant multiplication of 7 here. What we can do is we can take the 7 to the front. and we can rewrite this limit as limit x approaches 0, 1 minus cos x divided by x. Now we have brought this one to this pattern, so we can substitute the 0 for the whole thing. So this is going to be 7 times 0, that is equal to 0. So the final answer for this one is 0. Let's look at another example. I'm going to go ahead and erase this one. Let's say we have a question like this. Limit x approaches 0, and the trigonometric function given as sine x square divided by x. And you know, like whenever we have a sine, you have to think this one. Limit x approaches 0, sine x over x. Can I bring this one into this pattern? We have to have this value, and this value has to be same. What is the value next to sine we have? We have x square. So if I want to have the denominator x square, I have to multiply numerator and the denominator by x. If I do that, this is I can rewrite this one as limit x approaches 0, sine x square divided by, I multiply this x and x, that's going to be x square, and we have a x multiplied here. So now you can see we can write the whole thing as 0, but the only thing with difference is here we have x approaches 0. So to make that one also x square, what I do, I make it to y, like y is equal, let's say y is equal to x square, and x multiplied by any constant, like if x approaching is 0, the power of x, any power of x will be approaching 0 as well. So therefore we can also write limit y approaches 0 and sine y divided by y. And for this one, I take the limit separately. Limit x approaches 0, x, and if for this one we can substitute 1. So this is going to be 1 multiplied by here we can do the direct substitution, that is 0. So 1 times 0, that is 0. The final answer here is 0. And that's it for this video, guys. Thanks for watching. See you guys on my next video.